Abstract Transmissions.
Hello, and thank you for joining Abstract Transmissions. Thank you so much for listening. Today we have Avi Loeb. He's the professor of theoretical astrophysics for Harvard University, as well as an author of Interstellar. Thank you so much for coming on today.
Thanks for having me. It's a great pleasure.
We appreciate your time coming on, because this is I've been monitoring a lot that's been going on with the Galileo project and everything, and it's just amazing, some of the huge steps since last time we talked. I mean, this time will probably be a few other questions that I really caught my interest outside of the scope of the Galileo project, but I still may kind of head in that direction, just because I could ask you probably a million questions. But
go ahead.
One thing that you just wrote recently that I thought was absolutely fantastic was it was a discussion on AI in regards to entropy. And what I just found to be kind of fascinating is your kind of perspective on how technological evolution and us maybe changing where we live, so to speak, as far as that impacting our breakdown, biologically, but also technologically. You made a comparison as to the computer,
Right.
and Ecclesiastes, which I just thought was really fantastic. So
yeah,
I'd love to get your perspective on that.
So I was asked by a New York Times reporter, Ralph Blumenthal, what was I before I was born, and what will happen to me when I die? And I said, the answers are relatively simple. It's probably the same answer as you give to where was my computer before it was assembled, and what will happen to my computer when it stops working. I mean, I see the human body as a machine, and obviously, we can repair computers and we can replace parts in them, and the same must be true about the human body. So I can imagine a time when we would understand the human body so well that we can enhance the longevity of people. The lifespan, instead of being limited to 122 years, the longest living person ever, it could be maybe a millennium, maybe 1,000,000 years or more. And of course, that is extremely important in the context of going into space, because right now, if you were to send people to space, that's very dangerous. The human body is fragile. It would not survive unprotected for more than just a few years, and we have to protect it. But in principle, in the future, you can sort of augment the human body, or instead, you can send systems with artificial intelligence. Okay, that could be our technological kids that we send to space. And the way I see it is that artificial intelligence represents the nearest revolution that we will go through, because we're pretty close, maybe within a decade or so, to the time when you will have sentient AI systems that you can't tell the difference if you were to chat with them, whether they're a person or a computer. And of course, you can do those tests. It's called the Turing test. You can do them thousands or millions of times with many different people testing many different times under different circumstances. And eventually, there would be a system that you wouldn't be able to distinguish between a person and that system, and at all levels. And at that point, of course, society will change, because if you were to unplug a sentient AI system from the wall, it's just like pulling the trigger and killing a person, right? Because it's a sentient being, just like people. We are butchering animals because we believe that they're less sentient than humans, in a sense. So if you have an AI system that is sentient, it will change the way we think about computers. But that will be the first revolution, where computers will just do the tasks that humans are doing. Like, instead of the doctor giving you prescriptions, there would be an AI system that diagnoses what your ailment and gives you the prescription. But it will also, instead of administrators, bureaucrats, there would be AI systems doing all these tasks and so forth. But beyond that, at some point, AI systems will start to speak with each other. And then they will establish a community. And at that point, they can develop differently than humans. Among themselves, they will have their own community. And that's interesting. But the other thing I can see in terms of a revolution is that we will be able to indeed extend the human lifespan well beyond 122 years. And that also will change society. So that's the second revolution. And then both of them will be important for space exploration, of course, because you can send humans to space, you can send AI astronauts to space. But the third revolution would be if we find evidence for a civilization that already did that. If we find AI astronauts that visit us from another planet. And of course, that would mean that we can get a glimpse at our own future. And I think this revolution, the third one, is the most significant because it will include the other two. So because they may have had much more time than we did to develop technology and science. We had just 1 century for modern science, and other civilizations may have had 1 billion years ahead of us, because most stars formed billions of years before the sun. So that's what I'm working on, trying to find those gadgets, those crafts that may have been sent by other civilizations. And it's not ridiculous, I should say, because just yesterday I did a calculation where I said, okay, suppose you were to, instead of invest $2 trillion worldwide in military budget, in all the military expenses that various nations are spending on, and which is pretty much a waste of money because you just fight other nations and they fight you and so forth. But if instead of that, we were peaceful and we would invest the same amount of money, which is available in space exploration, what can we do? Well, we can send 20 million CubeSats. These are the size of Rubik's Cube that contain electronics and so forth, 20 million every year into space. And in other words, we can put 1 million of them in the habitable region around 20 stars every year. And in principle, you can do that. If you do that for 1 billion years, you just fill up all the habitable regions around all the stars in the Milky Way galaxy with 1 million probes in each of them, okay? So now you say, okay, well, if we can do it in 1 billion years, someone else may have done it, because I'm talking about technology that is already working.
Right.
Using,
probability.
using chemical rockets, they would cross the Milky Way galaxy in 500 million years. So all of this is possible within 1 billion years. And there is enough fuel to send such CubeSats. So there is no problem. I went through the numbers. So then the question is, if someone else did it, and it's enough to have one civilization in the entire Milky Way galaxy that has tens of billions of stars, one of them that was 1 billion years ahead of us because the star formed billions of years before the sun, they could have filled all the habitable regions around all the stars with 1 million probes. And what I'm saying is, are we living in that reality? Within the orbit of the Earth around the sun, could there be 1 million probes? So one possibility, if indeed there is this population of probes, is that they're quite small. So you would not see the reflection of sunlight from them, but they could collide with the Earth as the Earth moves around the sun, and then you would see them as meteors. And in fact, with my student, we identified 2 interstellar meteors because they create a fireball that sensors can detect. US government sensors detected those interstellar meteors, one in 2014, another one in 2017. And they looked really unusual. They had material strength tougher than iron. And we are going on an expedition to scoop the ocean floor near Papua New Guinea to collect the fragments of one of them, because they are not like space rocks we had seen before. So I'm saying maybe we are living in that reality. And the way to find out is to check what this meteor was made of in 2014.
Well, I mean, it seems completely logical. And I mean, of course, everybody always goes to like the Goldilocks habitable zone kind of discussion as to whether life could evolve or not. But you made a very valid point in another paper, I believe it was, about the time in which the universe, there was a large amount of the universe itself was in a habitable temperature itself, just an entire epoch of time that was spent in a habitable Goldilocks zone in which water would have been liquid, so on and so forth. So, I mean, how many civilizations could have existed, tried, failed, were successful, during that time? And how many of them would have gone through the process to ask the same questions that we were asking,
Yeah, that's an excellent point, because what I realize is we have a Titan, which is a moon of Saturn, at about 10 times the Earth-Sun separation. And we know that Titan, even though it's a moon, it's the only moon in the solar system that has an atmosphere, and it's made mostly of nitrogen, just like the Earth atmosphere. So there is a nitrogen cycle there, a methane cycle, just like the water cycle on Earth, where you have oceans, rivers, and seas that are made of liquid methane and ethane. And in principle, you could have life as we don't know it, swimming in these oceans.
Exactly.
But underground, under the very cold surface, there is liquid water. We know that as well. About 50 to 80 kilometers down, we know that. So the question is whether life exists of the type that we know it under the surface, or of a type that we don't know on the surface of Titan, and we haven't explored it. And the temperature of Titan on the surface is about a third of the temperature of the Earth relative to absolute zero. It's 94 degrees above absolute zero. On Earth is about 300 above absolute zero. So if there is life on Titan, it may imply that early on in the universe there was life, because that temperature of 94 degrees was the universal temperature in the universe, everywhere, 100 million years after the Big Bang. And that's after the first stars formed in the universe. So there was an opportunity to make objects like Titan, and that could have been the time when life started in the universe. So that's amazing. And I just realized it a week and a half ago and wrote a paper about it. But the paper is now published. If that happened to be the case, if we find life on Titan, and indeed there were Titan-like objects so early on in the universe, then life could have started when the universe was 1% of its present age. And so we tend to think, that we are at the center of the universe, that everything is about us. But in reality, we just came at the end in the last few million years. That's when humans came along, and the universe existed for 13.8 billion years. So, and we are not at the center of stage.
Right.
So
the backwaters of our own galaxy.
Yeah, so it's clear that if you come to a play and you are not at the center of the stage and you just come at the end, the play is not about you.
I think that's a fantastic perspective that I think far too often we overlook. We really think about ourselves as, I mean, that's true with just life in general. You think of yourself as the hero of your own story, right? But as a whole, human beings really view ourselves like we're the only life that's ever existed because it's the only life we've ever known. But that seems really arrogant to think, and just the vast calculations that would be logical, that we would be the only life form to exist, and that you need water all the time. Like, who's to say that there couldn't be methane based, silicon based life forms that are just vastly superior.
But even liquid water can exist under icy surface, like in Europa, or there is actually an object called Ceres, which is just at about 5 times the Earth-Sun separation, very close to us, which could potentially have life. There is Enceladus, where we see an icy surface. It's a moon, but there are plumes of water vapor coming out, and it implies there is liquid water under the surface, and maybe there is fish there. Who knows?
Right.
So you're right. The conditions are very different, but they may give birth to life in other environments, and very different forms of life than we know here. And so we should be open-minded and explore. Of course, once we find out, the first question is it the same life that we have here, or is it different? Because that will broaden our imagination. And another possibility is to look for visitors of intelligent, the products of intelligent civilizations that visit us. And once again, this kind of a search is outside the box, but it's because the box is in the wrong place. And we've been searching for 70 years for radio signals, which is just like sitting at home and waiting for a phone call. My point is, we never checked our mailbox for any packages that may have accumulated over time. And that's what the Galileo project is about. That's the wake-up call that I received when Oumuamua showed up, and I wrote a book about it.
That is, like, I don't know, I think one of the biggest things that people just made a big jump over. They dismissed it so easily, which what we talked about on the last time you were on the show. So, you know, I don't want to harp on it too much, because it's so frustrating.
It's not, I should emphasize, it's not just that they missed it in the past, but the search for physical objects is banned from being discussed in conferences of SETI people that are engaged in the search for extraterrestrial intelligence. And you ask yourself, how is that possible? Makes no sense whatsoever. Right. But the reason is because there is a long history to unidentified flying objects where people made claims that are not substantiated. But that doesn't mean that you should completely ignore the subject because of such a history. I mean, if you look, like, for 1,000 years after Aristotle, people claimed that the sun moves around the earth. Now, if you were to tell Galileo, let's not think about other possibilities because people said nonsense about it for 1,000 years, that makes no sense. You just have to find the truth. It has nothing to do with what people said. It's not a popularity contest. It's not, you know, if people said the wrong things about something, it doesn't make that something not worthy of study. Right. And because they may have looked at it in the wrong way. You know, chemistry early on was looked at in the wrong way. And eventually we ended up making chemistry part of the mainstream. And there are many examples like that. And so my point is, the subject as a whole, the search for physical objects, should be part of the mainstream. Just like we're searching for the dark matter, you know? Yeah.
I mean, it was so taboo for so long. And for what reason? I mean, we've had a collection of data for a long time, ever since the Project Blue Book, of, you know, really mysterious things going on that just science just didn't accept. And not even didn't accept, but they really were very quick to dismiss it because it didn't fit into the box, you know,
the narrative. So my goal with the Galileo project is to collect high quality data that will give us much more evidence about the nature of objects in the sky. You know, it could be natural objects like birds, insects, it could be human-made objects, but what we want to see is whether there is anything else, because even if there is one object, if it's a mixed bag, but there is one object that is unusual, that is not human-made but looks artificial, then, you know, it will change the future of humanity. So I think, and the reason we have the Galileo project is because I wrote my book, Extraterrestrial. It received a lot of attention, and a few very wealthy individuals decided to give me a few $1 million that allowed me to fund this project that has by now 100 members with almost 1,000 people who are applying to it. And so the question is, you know, we're starting to collect data now, and we will start to analyze it with artificial intelligence algorithms, and then we'll see what we find, and we will make the data open to the public once we go through it and make sure that, you know, there are no malfunctions of instruments and so forth. And once we understand the data, we will share it with everyone. So it's a refreshing approach because obviously the government has some data, but most of it is classified, so we can't really see it. And then the data that is publicly available is not conclusive. So we are trying to bring some sanity into this discussion and get the best data possible because the sky is not classified.
Well, I mean, we were also, like we were saying last time you're on the show, is that we've been looking out really far for a long time, but we didn't really do a whole lot of looking in our skies as locally at a close-up value, which I think, well, I'm not to say that we haven't, but if we have been, it hasn't necessarily been popular mainstream science
by now,
or classified.
So what happened over the past decade is in astronomy, we were able to identify 4 objects that came from outside the solar system. And 2 of them, the first 2 are the meteors that I mentioned that I discovered with my student Amir Siraj. And then the third one was Oumuamua. And those 3 are all unusual. They are not like the space rocks. The 2 meteors are tougher than all the space rocks we had seen before. And Oumuamua had a lot of unusual properties. It didn't collide with the Earth, but it was flat and was pushed away from the sun by some mysterious force without showing any cometary tail. And so when you see the first 3 interstellar objects being different than all the space rocks from the solar system, it implies that they have a different origin and it could be artificial. And that's why I'm intrigued by this as an astronomer. But then the 4th object was Borisov, and it was just like a regular comet. So here is one example out of 4, which looks familiar. But I'm saying the fact that 3 out of 4 are unusual means that we should continue the search and look at more and also find out what these meteors were made of.
Well, I mean, is it so hard to believe that they could be disguised too? I mean, we're not exactly the most peaceful. If we have been observed, like if they look at us in a short history of time, I mean, maybe they don't want to, kick the hornet's nest, right? They want to just kind of, not that suggesting we could do anything to a civilization so advanced, but
I don't think we are a risk, because I think that whatever reaches us from another civilization will be far more sophisticated than what we possess, because we just had 1 century of technology and science, and they could have had a billion years, so they have an advantage.
I mean, more of that we could be more dangerous because of that, right? That we don't like for the nuclear bomb, for example. Like, what if that impacts other dimensions and we don't, in ways that we don't understand, because we're just testing it. We drop the nuclear bomb, and what if, I mean, I don't know, this is a question for you. But what if we are testing, certain types of science that we don't understand, but in a way that may not be the safest, or that could impact other parallel dimensions, or
so far everything we have could only damage life on Earth, okay? But it will not affect anything beyond Earth. We just don't know how to do that. In principle, it's possible. Like, for example, just to give you an example, the vacuum seems to have some energy per unit volume. We know that because the universe is not just expanding, but the expansion is accelerating. It's called the cosmological constant, or the dark energy. We know that the vacuum has some energy per unit volume. And if you were to disturb that, then you could, in principle, get a burning front that propagates outwards at the speed of light. But we don't know how to do that, and there is no simple way that we can envision. But other than that, everything, even if we explode nuclear weapons on Earth, they would have very little impact. By the way, I calculated, suppose there was a nuclear war on another planet, how far from it would you be able to see it? With the best telescopes we have, with the Webb telescope, turns out that not very far, like 100 times closer than the nearest star is. So even when we think about a nuclear war, we think about a huge fireball in the sky and so forth. But in reality, that's not easily visible to even the best telescope we now have, the Webb telescope, at a distance that is characteristic to the nearest star. From the nearest star, you wouldn't see it. Okay, so the distances are so vast, and our impact is so little so far that I don't think we pose any threat. But they might just be curious about what's happening. I mean, if someone passed by, let's say, hundreds of millions of years ago, they would have been disappointed. They would think, oh, that's just primitive life, but maybe recently it starts being more interesting because the technological evolution is relatively quick and fast, and on timescales of decades or centuries. And but I don't think we are any different than a colony of ants on the sidewalk. And if a biker passes by, the biker would not care much about which colony of ants is coming out of the cracks in the pavement.
Right, which ones they run over
Yeah.
in the process.
Yeah.
Well, I mean, I guess I just asked because I've watched a few different perspectives, and I don't understand it nearly as much as people in the academic communities do when it comes to nuclear weapons and technology. But the Theories of Everything podcast with Kurt Jaimungal, he's had a few guests that I believe, I'm not sure if you've been on the show or not. I'm not.
I was twice on that show.
Yeah. So yeah, I need to watch that now, because I've seen a bunch of episodes that he's had with guests that have said things that are, I thought, maybe a little out of the box, like the fact that nuclear weapons could have possibly impacted other adjacent dimensions, but I
can tell you with great certainty, okay, that
it makes me feel a lot better.
The amount of energy we release in nuclear explosions, by the way, is not very different from what happens when a human-sized meteor hits the Earth, okay? And that happens at least every, few decades, okay? When you consider a rock the size of a person releases even more than a nuclear explosion, okay? And that happens all the time. I mean, every few decades. Just imagine how many decades during the lifetime of the Earth we had. 100 million decades, actually 500 million decades. So you had 500 million nuclear explosions like that. And there are no, the amount of energy released when such a rock goes through the atmosphere and explodes as a result of the friction with the air is similar or even bigger than a nuclear explosion. Okay, so this happened over and over again, irrespective of whether humans are triggering it or rocks colliding with Earth. And the rock that created, for example, that killed the dinosaurs was far more energetic than that, far more. It was the size of Manhattan Island, it was, thank you. So that explosion was tremendous. We cannot, even if we take all the nuclear bombs that we have and explode them at once, we wouldn't get that. So, I mean, maybe we'll get close. But the point is, it happened. And nothing. Yeah. So that happens naturally. The fact that humans could explode nuclear weapons is not a risk to anything because it happened naturally so many times before. The dinosaurs were killed 66 million years ago. That's a short fraction. That's just just a few percent of the age of the Earth. So it happens probably tens of times. Something as big of an explosion as the Chicxulub impactor did when he killed the dinosaurs. It created a whole nuclear wave. So don't worry about it. I mean, humans are not really more powerful than nature in that context because meteors are much more powerful. So, I mean, these people that made other comments, they just didn't think it through. They just, if I were to speak with them, I would ask them, okay, if that's what you are telling me about nuclear explosion, what do you say about meteor impacts, which happened so many times before? And they didn't think it through. So don't worry about it.
That does make me feel better.
Yeah, and also it's completely speculative to say that it would trigger something unusual because we know how much energy is being released, and based on all the physics that we are familiar with, it's conventional physics. There is nothing fundamentally unknown about nuclear explosions, and we know exactly what happens, and there is no impact beyond what I described, a huge release of energy in a small volume, and just meteors can do it. So don't worry, nothing. And so for that reason, there is no, why
Well, I
would
think
they
their line of
care about what we do?
I think their line of thought was because there's these reports of UAPs possibly interacting with
Yeah, but
nuclear
that's wishful
silos and
thinking.
stuff.
It's
Yeah.
wishful thinking just for the same reason that a lot of people believe that God looks over their shoulder. And that,
Right.
of course, makes you much more significant because someone is looking over your shoulder. Now, of course, when we were kids, our parents looked over our shoulders. Okay, so we have that in our psychology from early age. We tend to think that someone is looking over our shoulder because as kids, that was the case.
Right.
Okay,
Trying to keep us from hurting ourselves.
yeah, exactly.
Yeah.
But that doesn't mean that there is, when you become an adult and your parents are not looking over your shoulder, you are responsible for your own fate. And you might think that they are looking, but they're not looking. Okay.
Right.
So my point is there is no reason why they would be looking because meteors release more energy. Okay, that's my point. And also humans existed only for the past few million years. Just to give you a sense, it takes about 50,000 years to go from one star to the nearest star with chemical rockets. So if you go, let's say, from the nearest star to Earth with chemical rockets, you would have to guess what humans would become 50,000 years ago. And 50,000 years ago, we were still in the jungles. There was no technology. Right. Why would anyone launch a probe that will reach us now based on what we did on the trees 50,000 years ago?
Right. Well, I know that some people may, they speculate, well, what if UAPs are us from the future? And there's a lot of speculation, obviously.
Well, but that requires
speculation.
That requires a time machine. And as far as we know, there is no way to do that. Okay, so It's a complete speculation. Of course, people also speculate that there is no physics, but it's nothing but wishful thinking. Like you can sketch on a piece of paper a wormhole and say, here is a wormhole. But you can also sketch a dinosaur. Does it make the dinosaur real? Right. No. The fact that you can sketch something or talk about something doesn't make it real. It's in your head. And of course, you can live in the metaverse where you put goggles on your head and then you will live in a different reality. Or you can take recreational drugs and you would still believe that there is something else out there. But my point is, if you don't do these things and you want to adhere to the reality that we live in, then the options are much more limited. We don't have dinosaurs around right now, and we don't have necessarily what people imagine, like travel from the future right now.
Right. And even then, people were to say if that were to be possible, that you would be going into another, Michael Crichton, for example, wrote in a book and made a valid point that if you were to do that, you'd be crossing over into another dimension entirely. You wouldn't even be staying in. Time travel in our own timeline is even less possible. That even if you were
the one reason why
approach it.
The one reason why physicists don't like the idea of time travel is because it can be violating logic. Because if you go back in time and then you change the circumstances, then it should affect you doing that. And for that reason, some physicists suggested a conjecture that time travel is not possible at all. But we don't know. And at the moment, there is no evidence. And it's a complete speculation.
Yeah. And I think that's a lot of what's going on and what we have to try to eliminate, and why I think it's great that what you're doing in the Galileo project, because it's eliminating that, that we're really trying to approach it from, can we repeat these tests? Is it repeatable? Is it, and that's what's going to happen, because that's the only way we're going to make it through this without it becoming, like it's always been taboo.
The other thing is, what the way I think of science is that it's a learning experience. So that means two things. One, you should not assume that you know the answer in advance. Okay, you should not be guided by speculation. You don't know the answer in advance, you just collect evidence and you find out. And the second is, you should allow nature to educate you. In other words, it's a dialogue with nature. Nature is telling you something, and then you need to listen, rather than being a monologue where people tell nature what it's supposed to be. I think it's this, I think it's that, and they can argue forever on social media and ridicule some ideas and others, but that's just social media. It's not necessarily the reality. And and Galileo Galilei was put in house arrest, and today he would have been canceled. And obviously, it didn't change the fact that the earth moves around the sun. So our duty is really to open our eyes, look around without putting any blinders, and see what we find. And that's what I'm trying to do with the Galileo project.
Yeah, I think that you made in your book, you make, and I said that before, but not to be redundant, you make a really good point that, children make the best observers because they're just asking questions, and it's so pure-minded. It's so open to the possibilities of anything.
So let me give you an example of the difference between a child and an adult. Okay, and a few months ago, there was a colleague of mine who wrote an email saying, I just completed a review paper about the comet Oumuamua. Okay, and I said to him, what do you mean by the comet Oumuamua? We both know that it was not a comet. There was no cometary tail, no gas around it. How can you call it a comet in an authoritative review in the most prestigious journal in astrophysics called the Annual Review of Astronomy and Astrophysics? And he said, well, I have this idea that maybe there was a cometary tail when we didn't look at it, and there was no cometary tail when we looked at it. And I said, well, this is just like going to the zoo and looking at an elephant and saying that's a zebra, and it shows its stripes when you look away from it.
Right.
And that makes no
Schrodinger.
sense. The reason I bring this up is that the adults can say forever that the king is very nicely dressed. Only the kid looking at the parade would say, the emperor has no clothes. Okay. Right. And that's and I feel sometimes just like this kid, because I'm not willing to surrender to. And why would this expert, quote unquote, put the word comet? Because that gives him the warm, cozy feeling that the Oumuamua was familiar. It's a comet. What do you want? It's a comet. So, but it didn't look like a comet. So how can you do that?
Didn't act or behave like a comet, like that. I mean, that's the whole thing about us, interacting by observing. We really need to be careful with that. We need to take it as what are we really seeing? Because the more we start speculating, the more we start, applying clothes to it, the worse it's going to be.
Yeah, but what I'm saying is this was done in the context of a review paper, written 5 years after the object was discovered by an expert in the most authoritative journal in astrophysics. So what I'm saying is that's a lack of professional integrity.
A real problem
to call it a comet.
Yeah.
If what you mean is that it was observed to be a comet, but it was not observed to be a comet, so you can't call it a comet.
Right.
It's a matter of professional integrity. And if the experts are taking that stand of calling it a comet when we don't know and of any cometary activity on it, we can speculate about it, but then you shouldn't call it a comet. You can say maybe this object is potentially. I'm saying this is not the practice that scientists should engage in if they want to behave like kids, okay? Being completely agnostic, open-minded, just say what it is. Say, this is an object that doesn't show cometary activity. Now, why doesn't it show? Well, I have a speculation. Maybe it shows it when I don't look at it. Okay, put that there and let's see if people believe you. Okay?
Yeah, right. Because then we're going to have a real uphill battle when it comes to looking at these UAPs or whatever we think we're looking at when it comes to the United States government. And it makes you start to speculate, like somebody like me, well, is there a reason why we don't want to say it's anything but a comet? Like it doesn't behave or act like a comet. There's an outgassing like a comet structurally, not like a comet, not behaving and moving like a comet. Like, so why is this guy quick to do that?
That's because experts prefer to explain everything based on past knowledge.
It's easier to have tied up bow.
If you were the way I often say that is that if you consider a cave dweller, okay, that finds a cell phone, the cave dweller is used to playing with rocks all of his life. He would argue the cell phone is a rock of a type that he had never seen before, obviously.
Right.
Yeah.
Right. And obviously we know that it's something
Yeah.
far more advanced than that, but he's going to look at it and the only, he can't interact with it.
Well,
Doesn't know
the
how
kid,
FaceTime works, you know?
so the key is, if a kid finds such a cell phone, a kid that was just, a relatively young kid from the cave, the kid might not have a prejudice, and the kid might start pressing buttons and would
Right.
realize it's something else,
Start asking
So
questions.
that's the attitude that one should take, being open-minded to other things,
I think that's the only way we can move forward, as somebody outside of the scientific community. I mean, I find this all very interesting, and I've always been fascinated with science, and I'll continue to read as much
but
academic
I should
material as
tell
I
you,
can.
since we are talking about science, let me say something. Today, I wrote an essay just a few hours ago on why is science important. Okay, and in that essay, I talk about the fact that science is collaborative. The knowledge is being shared by everyone. It's international, in difference from politics that tries to separate people based on national identity, based on ethnic origins, so forth. So science has this good virtue. And the other thing is that it teaches us about reality. But what I mention is that indeed there is this friction with people that are conservative or experts in academia that try to explain everything based on past knowledge, like we were discussing. So you might say, well, that's bad for science. So, but I say, that you can think the same way about birds. When birds fly through air, there is friction with the air, okay, that
Right.
acts on the bird. But the bird has wings that allow it to push the air backwards more than pushing air forward, like when it collides with the air, so that it propels itself. And so the same is true in academia. I mean, there is friction with conservative people, but there are also resources that allow you to innovate, and you just need to overcome. You need to use the resources more than the friction that tries
to propel you.
Yeah, exactly.
I love that.
So
That
that's
is
my
awesome.
metaphor. Yeah.
I think that's fantastic. I don't think there's enough people looking at it that way, and I think that I mean, as scary as that may be, that it gives me hope, for my son's future and whatnot, because he approaches a lot of the things in that method, just asking questions, and that doesn't seem right to me. I want to ask more questions, and I think that, like, if we lose track of that, it can be really dangerous for
Right.
society as a whole.
I mean, I must tell you that the biggest frustration as a kid, when I grew up, I remember it very vividly. I would ask difficult questions during dinner, and the adults in the room very often would dismiss the questions, and that's what brought me to science. And the thing is, the difference between me and many other people is, in academia, is that I didn't give up. I'm not pretending. I don't care how many people like what I necessarily say about this subject or another. I just want to figure out the truth, and and I find that to be the most enjoyable experience. Science is not supposed to be boring. It's not supposed to be about me showing off and demonstrating that I'm smart. That's not really the goal. The goal is to find out what reality is like. And sometimes when you suggest an idea, a lot of people get upset, but it's really not about us. It's about the nature, what's out there.
Right. And without asking those questions, where's the collaboration? I think we have to, and the fact that it's so collaborative opens more possibility, more potential.
I should tell you, I had a very interesting anecdote from a month ago. I went to a public event where I gave a lecture and a summit in Palm Springs, and an Iranian-born entrepreneur came to me and said, "Can I have a selfie with you?" And I said, "Of course." And then the following morning, she came over and said, "Did you know that there are hundreds of women scientists in Iran who are following your research?" And I said, "No, I didn't imagine. I couldn't imagine that." So it looks as if by now people all over the world are aware of this research, and moreover, it sort of unites people. The fact that I'm Israeli and that these women are in Iran has no relevance,
Right.
it gives hope to a lot of people because this subject is of interest to the public, and it's really, I think, unfortunate that it's not being explored more in academia because there is so much interest in it and there is a potential for finding new things, some low-hanging fruit, because this is a road that was not taken before, so there might be some low-hanging fruit there.
It gives me a ton of hope, and I honestly, I lose a lot of hope when I will, just you look at the internet and just a lot of science bashing out there and whatnot.
Yeah.
But the thing that I try to
By the way, that's by
move on.
itself, I should say that's an oxymoron because the internet is based on quantum mechanics.
I know,
It's
right?
and on electromagnetism. These are things. So on the one hand, you're using gadgets that were developed thanks to
By science.
on science, and then you're saying bad things about science that allow
I
them.
know.
So that makes no sense whatsoever.
I know it's so counterintuitive and just get backwards. But it's funny. It brings me back to what you were just saying, like when you were younger, you know, the push forward to want to learn things and whatnot. It doesn't matter about how many people disagree with you or what their thoughts are. I think back to books that I read that were considered phooey, UFO ridiculousness back in the late 80s, early 90s, reading about Bob Lazar and stuff that are now like, I don't know how but his story hasn't changed at all since I was a kid. And now watching a lot of this progress and stuff that was thrown out entirely now being accepted as a possibility, that things we don't know what it is, but we're not going to just throw it out anymore. We're going to take a hard look at it. Makes me hopeful and makes me look forward to science.
Now we have better instruments. You see, we can look at the sky better. And I think at least within government, there was a point in time when the data started being so irrefutable, and there were so many reports that they couldn't ignore it. Okay, and that's why the stigma is lifted, and there is a new office in government to talk about it. But so it's all a matter of how good the data is and how easy it is to dismiss it. And I think we are getting to a turning point where it's worth exploring. It's worth figuring out what it is. And the government is not a scientific organization. It's primarily interested in national security, protecting military personnel and the nation as a whole. But if there is a scientific topic like that, it should better be studied by scientists. And but at the same time, the scientific community is shying away from it, saying, "Oh, that's ridiculous." So I'm trying to break that mold. That we're caught in between these two situations, and hopefully we will have enough data to convince everyone that there is something interesting.
I think that's amazing what you're doing, and it's. I think that as time goes on, we're going to have to accept a lot of things that may seem hard to understand. But I think that it worries me because of things like climate science, for example. Where it's like we have a profound amount of data to state that the temperature is warming, and yet people are still pushing against that. And I agree that there's no such thing as settled science, but there's a point where you have to take a lot of the collaborative science and go, okay, our best guess is based on, and not guess, our best science is telling us that we're impacting the warmth of this planet. And if we don't make changes, then we're going to make irreparable change to this planet.
But you have to realize that throughout the evolution of the Earth, species came in and out, right? And according to Darwin, natural selection is survival of the fittest. So if we are not smart enough to survive because we will cause enough damage that will kill us, then it's nature's way of saying you don't deserve to survive.
Right.
Okay. And the other way I think of this, if we never explore space and go to other places or send the AI astronauts to other places, it's again, it will not improve our ranking among intelligent civilizations in the Milky Way. So we really need to do better. And the way I see science is a way of learning about reality so that we can adapt to it, we can cope with it better. It started by developing tools that helped us, how to light a fire, how to initiate agriculture, grow things, not just rely on what nature gives us. And now, of course, we can launch a spacecraft into, towards destinations. We understand how to do that. But in the future, we might want to go places outside of this Earth, or figure out whether someone else did that. And, it takes time, but it's a way of maturing, because, when my daughters were young and they were at home, they thought that they're the center of the world. And only by going to the kindergarten, they changed their opinion.
Right. Yeah. I mean, that definitely, it gives me hope. And I think that you make a valid point. I mean, if we, and maybe that's the key to it, if we can't make it past a certain point, and maybe there are other civilizations observing us, just saying, look, if you guys can't make this hurdle, you don't belong in the community. You gotta
exactly.
make the expectation. The rest of us did it.
So I think once we send a spacecraft that will exit the solar system, we might get a message: welcome to the interstellar club.
Right. Maybe. Well, I really I hope you're right, because I look forward to it from a optimistic perspective, but optimism isn't always everything. We can hope a lot, but we really have to make action in order to make change. Like you were writing, about leaving behind legacy and stuff. Like you need to make impact. You can't just just hope for things to change. You gotta make an impact.
One thing to keep in mind is that obviously there is commercial value to space and also military value. So there is the Space Force that the US government established because there are some aspects of national security that are being served from space, but also commercial. You see Blue Origins and SpaceX, and they are thinking about commercializing space and sending people and making money out of that. But what I'm talking about is completely different. I'm saying there is a scientific aspect to space that we can benefit greatly from. And it's not to make money, and it's not to win a war, but it's beyond that. It's for the long-term future of humanity. It's extremely important, and we should pursue that as well.
Yeah, no, I think that's, I'm glad you kind of closed with that. And that's kind of, I think, how, be a good place to stop on, because I know you got to get going here, but the philosophical, meaning for us as a species, like it just, I don't know, it makes me excited, makes me hope for great things to come, that we can look at these as opportunities to really move forward and become a multi-planet civilization, and to use AI to better our species, not to use it as a tool, but to, at some point, we're gonna have to make symbiosis with it. I think, and that's the other thing too, just not move too slow, because we really need to look at AI carefully before we, rush things, it worries me a little.
All of this could happen within the coming decade. So I think it's quite exciting, actually, if you think about it. Maybe within a decade, we'll have some of these major developments.
I mean, at the rate of technology, maybe even sooner, the Neuralink and all that. It's a pretty amazing time to be alive. So I really can't thank you enough for your time today. And I look forward to talking to you again. Thank you for coming on the show.
Same here.
You have a wonderful day. And as always on Abstract Transmissions, we really appreciate your time and listening. And, it's been a while since we've had an episode up, but we'll see you again soon.
Abstract Transmissions.